Welcome to Brain Vision.
To determine the tension in the cable, we can use Newton's second law. So the tension in the cable has two components. One component is this one, the vertical component, which counterbalances the weight. So let me call this Ty. And the horizontal component, which is this one. And this is responsible for accelerating the laser sensor. So we will apply Newton's second law in the x direction. Let me choose my reference frame as this. Everything that is pointing to the right is positive and everything that is pointing up is positive. Then, applying Newton's second law on the x direction results in the following. The net force in that direction is equals to the mass of the sensor times its acceleration in that direction. There is only one force acting on the sensor in that direction, and this is the x component of the tension force. And this is equal to the mass of the sensor, 129 kilograms, times its acceleration of 2.84 meters per second squared. And this gives an x component of tension that is equals to 366.36 newtons. Now, applying Newton's second law on the vertical direction, we get the following. The net force in the vertical direction is equals to the mass times the acceleration in that direction. But it's not accelerating in the vertical direction. So its acceleration is equals to 0, then the net force in that direction is equals to 0 too. But there are two forces acting on the vertical axis. The y component of the tension force minus the weight force. And this should be equals to 0. So the y component of the tension force is equal to the weight force, which is given by the mass of the sensor times the acceleration of gravity, which is approximately 9.8 meters per second squared. Therefore, the y component of the tension is equals to 129 times 9.8, and this results in 1264.2 newtons. Now, using this information, now that we have both the x and the y components of the tension, we can determine what is the magnitude of the tension force. Because the tension force forms a rectangle triangle like this. Here we have the y component of the tension force. Here we have the x component of the tension force. And here we have something that has the same magnitude as the full tension force. This is a 90-degree angle. Therefore, using the Pythagorean theorem, the full tension force has a magnitude that is equal to the square root of Tx squared plus Ty squared. Then the magnitude of the tension force is equal to the square root of 366.36 squared plus 1264.2 squared, and this results in a tension force of approximately 1320 newtons.